Welcome everybody, and thanks to be here to this session about creating intelligent application with Azure Logic Apps and private AI. My name is Stefano De Migliani. I'm a Microsoft MVP on Azure and business application, living in Italy. Here I will share with you my contacts where you can directly contact me if you need some more information or just to be in touch. The topic for today is one of the emerging topics in the AI world. Talking about private AI and why Logic Apps can be useful in order to start introducing private AI in a corporate. When you talk about AI when you try to introduce AI in a corporate, usually this is not an easy task, mainly because there are a lot of challenges. Corporates see some difficulty in introducing AI, and mainly this is because first of all, it's not always clear what task can be demanded to AI. So some corporate organizations have different reason to accept or not accept AI. There are a lot of concerns about cost. So AI can cost me too much or not. So this is usually a problem that you need to speak and explain to your customer. There are also concepts about data privacy and security. Sometimes sending your data to an online LLMs is something that a company feels like risky or a violation of their security rules. And sometimes there are also concerns about reliability. If I send my data to an online LLM, this is reliable or not. So there are a lot of topics that you need to discuss in order to start introducing AI in a corporate. And so why private AI is an emerging trend in at least the last 1 or 2 years? Because with private AI, users can create custom AI solutions that can deliver the result they need, that can train on data they have. So on your raw data, they can be able to perform the behaviors you want, not just random models that can answer random things, but models that are tailored to your business. And especially with zero or quite zero cost, because if you host an online privately, you don't need to pay for a third-party entity that ask you for a cost per token or something like that. So all these reasons by ensuring that your data never escape your control. So this is one of the main reasons where private AI is a very emerging technology. When we talk about private AI, there's some concepts that you need to understand. The first is that the difference between open and closed LLMs. Because when we talk about AI, we know that there are LLMs where we need to talk with. But LLMs usually can be divided into 2 main categories. Open LLMs. In open LLMs, we have full ownership and complete control of this LLM. So this is an LLM that you can simply take, make your own, and then this LLM has no solutions, is quite free to use because you host it, so you don't need to pay a third-party entity in order to use it. Obviously, the drawback is that quality sometimes not match closed LLMs because it's hosted locally, and so you have limited resources, and you need to host it locally, so you need to have the right resources in order to run a private LLM. The other side of the moon is the closed LLMs. Closed LLMs are models that are proprietary, so made by some entities like Anthropic, like OpenAI, or different other vendors. These models can be obsolete, so a vendor can decide that a model is obsolete and then retire and substitute with a new model, so you need to handle that. And usually these models, closed LLMs, are pay per use, so there's an higher cost because you pay for every token that you exchange input and output with these models. Obviously, the advantage is that in this case, with closed LLMs, you have full LLM power. So they run in large data centers. For you, it's totally transparent. You simply talk with them. They are provided to you as a service, so you cannot modify them. You cannot modify their behavior or train their data. You simply use it as a service. So in this session, we will talk about open LLMs. So open LLMs are really energy models. And here I've put the actual overview of the open source AI models in the world. These open source AI models are usually divided into 4 main categories. The large models. So large models are models, open source models that usually have more than 150 billions of parameters. And these are the main models in terms of intelligence, as you can see in the chart. And these are all models that you can host by yourself. Then there are medium models. Medium models are for 40 billions of parameters to 150. Small models and tiny models. The small models and tiny models are usually models that you can run in any local machines that you have. Tiny models also can run in devices. So you can also run these, for example, from a smartphone or a Raspberry or something like that. Large and medium are models that require, all these models can be run locally, but usually large models requires at least 64 gigabytes of RAM or more, while medium models runs on 32, 64 gigabytes of RAM. So these are all models that can be run locally in your own environment, in your own infrastructures, and that you can use for your own business. Obviously, first of all, you need to take the model. And these are all open models that you can simply download from the provider or directly from Hugging Face, that is one of the most popular open source repositories in the world. Then you need to have a server to run these models. And the tools that an LLM, first of all, can be run locally only if it passes a process. All these LLMs are something like children of big LLMs. So when you talk about local LLMs, you need to understand 2 concepts. The first is quantizations, and the second is distillations. The quantizations is the process that involves the reducing the precision of the models. So a very large model can be reduced in terms of precisions, and this reduces the memory footprints that the models requires. So these models can be executed in a small hardware requirements and less memory bandwidth also. Then there's the distillation. The distillation is the second process that I usually use this similarity. It's like training a smaller and simple model called the student to mimic the behavior of a larger model. So the teacher can, the student can learn from the teacher and can produce output that are similar to the teacher with much smaller parameters, so with much more hardware resources. And this is the main advantages of private AI. All these models are distilled or quantized from a largest model, one of the models that you are available online from all the main providers. And these are reduced version that you can use offline. To use this model offline, the third thing that you need is the hoster. So a tool that permits you to host and run this model offline in your own hardware and in your own infrastructures. And here I've put in the slides the main of these models. So the most famous, at least. Ollama and LLM Studios probably are the most famous, and the tools to run LLM locally that are also much user-friendly, because these are all tools that permit you can just install in every OS you have, so Windows, Linux, Mac OS. And then you can simply download the model from Ollama or from LLM Studio. This permits you to expose that model as a service, and then a local service, and then you can use from your own applications. Azure has also embraced private AI. Last year, the Azure AI team launched the Foundry Local platform, and the Foundry Local platform is exactly like one of the previously mentioned platform. So a platform that permits you to download models locally and execute those models locally. Then there are other more complex tools like Llama CPP, VLLM, or for example, for the macOS platform, there's the MLX framework. The MLX framework is very, very powerful and very, very fast. These are quite a bit more complex, but the result is the same. When you configure this tool and you download a model, an AI model offline, this tool permits you to run this model locally, and then you can use your model for any applications you have locally. So all data that is never sent to internet or is never sent to train an online model. Why Logic Apps and local LLMs can be interested in some real-world scenarios? There are different reasons for that, and there are different reasons for why, at least in my experience, I started proposing this type of solution in some scenarios. The main reasons are that, first of all, with Logic Apps, you can orchestrate AI-oriented workflows without exposing data to internet, so to public cloud LLMs. One of the main concepts that some customers have. I don't want that my business data goes into an online model, and this online model can use this data to train itself. So here, in this way, your model never escapes your internet, your local area network. The second is cost efficiency. Local LLMs avoids ongoing cloud API costs. So you don't need to pay nothing for reading, so for sending data to LLMs and receive the response from LLMs. So this is ideal for high volume and repetitive tasks. And the last advantages of this combo between Logic Apps and local LLMs is that with a local LLM, you can fine-tune that model with your specific data. So this model can work with your specific business data. It can answer accurately with your domain relevant outputs. And with Logic Apps, you can, in a low-code way, orchestrate processes that can also use local models for some tasks. And with all the benefits related to that. So you can have an agent running in Logic Apps that can, and this agent can have different actions, perform different tasks. Some tasks can be performed by, for example, an online model, like, I don't know, GPT-5, for example, or GPT-4o. While other tasks, for maybe more sensitive tasks, can be performed by and executed by a local LLM running in your own infrastructure, so without going to internet. And this is exactly what I want to show you in the last part of this session. So in the small demo that I've prepared in order to show how you can do that. And to do that, I've started with one of real-world scenario that we have proposed to some customers. So I use this, a more simplified version of this, just in order to try to explain one of the advantages. So in this example, real-world example, we have a company where the technical department of that company usually creates item records inside the ERP system. So these item records are created internally inside the company in a ERP system. And when the record is created inside the ERP system, a process needs to start. And this process one of the tasks that this process needs to perform is to generate marketing description for these items. So a long text that can be used from the marketing department, but without transmitting all the item details to an online LLM, because the company has strictly security requirements, and data related to these items cannot be sent offline to an online LLM. I want an AI model that is able to generate a marketing description according to all the data that I'm passing to you, but this data must be absolutely still remain private. How to do that? To mix a part of the process that must be private with some part of the product that instead should be executed by a standard online agent like GPT-5. Logic Apps was our choice. So I think that you know that Logic Apps has a feature called agent loop that permits you to create autonomous agents. And this was the agent that we created. As you can see, the agent starts from the advantage of the Azure Logic Apps platform is that you can use low code, and then you can use triggers and actions. So the triggers in this case is an event coming from an ERP system. And from this ERP, we call our orchestrator, so our main agent. And this main agent has free tools available here. And with these free tools, some of these tools are executed by an online model. Like, for example, the verify price list is a process that totally executed by the agent online. But when the agent need to generate marketing text, this must be executed by a local LLM. So this is the part that when the agent reaches this part, needs to call a local LLM. So not GPT-5 or other online models like the main the other tasks. But in this case, it's an action, a tool that must be executed by a private LLM. So how we create this type of scenarios? I want to show you in this demo. First of all, as I said before, a model must be hosted by a tool able to host models. And in this case, I've used LM Studio. But as I said before, you can use any other tool you want, or any other tool I mentioned before. This is not mandatory in order to do that. As LM Studio, as all the other models, permits you to expose a local an online model, a private model, sorry, as local service. So this is the local service that where LM Studio is exposing the model, and this is my model. So in this case, I'm hosting offline, completely offline in my machine, gpt-oss 120 bits. So one of the latest open source models available from OpenAI. Saying that, in this case, I'm creating a, first of all, the model must be, the local service must be put available to the model. So in this case, I'm using a tool to expose a local service to Logic Apps. And in this case, I'm using DevTunnel. DevTunnel permits you to create expose to a local an online service your local service. You can use also other tools like Ngrok or different others, but just remember that this permits you to expose an endpoint pointing to your local service with authentications and with something like that. Then we when this is done, we have go into the Logic Apps part, so our most interesting part. And here I'm creating an autonomous agent, one of these new features available in Azure Logic Apps that permits you to create autonomous agents running stateful workflows that can use AI agents to do tasks autonomously, so without user intervention and reacting with the events that can be from Azure or from different applications. In my case here, I have, let me close this. I have previously created these agents that, as you can see here, it starts from an event coming from an ERP system. In this case, the ERP is Dynamics 365 Business Central, the Microsoft ERP. So I'm reacting to an event in this case. So when an item is created inside the ERP system, I'm retrieving the details of this item. And when this item, the created items are details, these details are retrieved, here is where it starts the orchestration. So the agents, the main agent is GPT-4o online model. That is an agent responsible to generate marketing descriptions. But when you need to generate marketing description, you need to call the appropriate tool. And the appropriate tool is this tool called marketing text generation. And this tool calls my local LLM. So here is where I put the URL, now it's masked, of my local service running the LLM. And here is the message for the LLM. So I send it to my local LLM to create a marketing text for this item, passing the item name coming from the ERP triggers with some limits or with some rules. Here I simply create a very simple prompts. But here, as you can see, this is an action that calls my local service, not my online one. What happens in this case is if, let me show, go here, and if I, for example, I go into my ERP system and I creating a new item, I select, here is the ERP, so it's just for showing, I create an item called, for example, Surface Laptops, something like that. I create this item and I close this item. As you can see here, there's a bit of moment where you will see that the GPU will increase. And this is the moment that where the local LLM is executed. And if I'm going to check the run history of our workflows, you can see that our workflow is executed, and our workflow is executed, and the description, the item description is generated. So here I have my item description, that is meet the Surface Laptop where blah, blah, blah. So a long marketing description. And if I go into the details of this, let me reduce a bit the resolution, otherwise there's a problem. If I go into this, you can see that this marketing description is generated from a model that is my offline model. And this is the response. So here I have all the details about my calls. So my calls is not executed by the online models, but it's executed from my offline models running in my own environment. So in my own laptop in this case. So these the data coming from this ERP are sent directly to the offline models. So Logic Apps is able to, in this case, call the right tool, and the right tool is configured in order to call my offline models. And this is, as you can see from the trace, this is the response, and this is the output from the GPT, GPT 120 that is executed offline. So this is much a new, probably a new possible way to create AI solutions with Azure Logic Apps. Not only using online models, but also you can start providing solutions that uses models that you can host offline, totally private with total the total security that you have in your corporate network, because everything here is running inside your corporate network. So no data is sent to an online LLM in this case, but it's the local LLM that is responding. So also zero cost, because in this case, the cost of inferencing the prompt to your online model, to your offline model is nothing, because you don't need to pay for tokens in this case. So you can have multiple actions called these multiple models without paying nothing, simply because the model is hosted offline. Obviously, as you said previously, probably you said that this chart growing. Where's the limit of that? Hardware resources. So you need to have the right hardware resources to run the right models. But when I talk about private AI, I always say that online LLMs are extremely powerful. GPT-5 for just for doing a name is extremely powerful, but Do you really need the power of GPT-5 for every business task you have? Probably no, because like in this case, generating a marketing text with GPT-5 is too much. And you need to pay for, and if you have 1 million of items, you need to pay for 1 million of calls with, and plus for each calls, you have some tokens, input and outputs. That's a cost. In this case, you are saving costs, and also probably the main reason you are also saving privacy of your data, because your data still remains offline. So this is the scenario that I want to show you. So using agent loop, you can orchestrate workflows where some tools can also be executed not by the main LLM, the online LLM, but also can be executed by calling an offline LLMs. Probably there are scenarios where this fits, there are scenarios where this don't fit. It depends by your business case, but I'm quite sure that in many business case, this is a very powerful scenarios. And Logic Apps adds on that, because if you use Azure Logic Apps standard, you can also scale as you need. You can also parallelize workflows, so you can have create quite complex workflows that can satisfy these scenarios. This ends this presentation, because we are quite out of the planet time. I'm available for question and answer if you are interested to know more about private models, how to host private AI with Logic Apps. So feel free to ask questions or directly write in to me if you want to need some more. Thanks a lot, and see you